Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 2.4, Problem 19. This is Section 2.4, Problem 19. It says multiply the fractions, and we have three of them to multiply. 4 3/7 times 6 1/3 times 2 1/2. So when we multiply fractions, I want to do the numerator times the numerator, or in this case, numerator times numerator times numerator. Now the problem is that I don't have just fractions with numerators and denominators. I have mixed numbers. There's a whole number mixed in addition to the fraction. So before I can multiply, I have to rewrite this problem with only fractions, only numerators and denominators, no mixed numbers. So I will convert them to improper fractions. So for each one, I will multiply the denominator times the number in front. So for the first one, I'm multiplying 7 times 4, which gives me a result of 28, and I take that result and I add to the numerator. So I will add 28 plus 3 is 31. So my first fraction of 4 3/7 can be rewritten as 31 over 7. This way it's not a mixed number anymore. There is no number in front that I need to deal with. Times, now the next one, 6 1/3, so same process. Multiply the denominator times the whole number in front. So I will multiply 3 times 6, which will give me a result of 18. Then I take that result that I got and add it to the numerator, which would be 18 plus 1, which is 19. So my second fraction, instead of 6 1/3, can be written as 19/3. Again, now it has only a numerator and a denominator, no whole number in front. And finally, the last one, same process, 2 1/2, convert that to an improper fraction. So I will multiply the denominator of 2 times the whole number in front, which is also a 2. So I have 2 times 2, which gives me a 4. Then I take that result of 4 and I add the result I got, 4 plus the numerator. 4 plus 1 more is 5. So my last fraction is 5 over 2, or you could say 5/2. Now all three fractions are written without the whole number. So now I multiply across the numerators. 31 times 19 times 5. Those are some big multiplications. So this is the point where you want to check, can I reduce those numbers? Can I make them smaller? So 31, will it reduce with 7, 3, or 2? No, it won't. The 19, will that reduce with 7, 3, or 2? It won't. The 5, will that reduce with 7, 3, or 2? It won't. These are all prime numbers, actually. I could see that they would not reduce. So I just have to multiply those numbers out. So in the top, let me just go off to the side and multiply. I'll start with 31 times 19. So 31 times 19. So 9 times 1 is 9. Nothing to carry. 9 times 3 is 27. And then I'll multiply 1 times 31, but I have to put in a 0 to hold my place. Then 1 times 1 is 1. 1 times 3 is 3. And then I add the results together. 9 plus 0 is 9. 7 plus 1 is 8. 2 plus 3 is 5. So when I multiply 31 times 19, I have 589. Now don't forget, I'm not done yet. I still have to multiply that result times 5, right? I have to multiply all the way across, top times top times top, because there's 3 fractions. So take the 589 that I got by multiplying 31 times 19 and multiply that times 5. So just leave the 589 here. Underneath it, I'll go times 5. So 5 times 9 is 45. Write the 5, carry the 4 to the top of the next column. 5 times 8 is 40, plus the 4 more that we carried. 40 plus 4 more is 44. So I write the 4 from the 44, the right 4. Carry the left one in the tens position to the top of the next column. Now 5 times 5 is 25, plus the 4 more that I carried. 25 and 4 more is 29. So now 31 times 19 times 5 gives me a result of 2,945. Now the denominators will be a little bit easier. 7 times 3 times 2. Well, 7 times 3 I know is 21, and then 21 times 2, if I double the 21, I have 42. Now that is the answer. 2,945 over 42. Notice it is an improper fraction. And if the directions for the problem don't specifically state that you can't leave it as an improper fraction, then that's good. You're done. Now, if the directions state that you cannot leave it as an improper fraction, what you have to do is see how many times the 42, the denominator, will divide into the numerator of 2,945. So, let's see what we get. 2,945, and we will see how many times the denominator of 42 will divide into it. 42 does not divide into 2. Next, it does not divide into 29. 29 is not big enough. So 294. Now the 42 will go in. How many times? Well, just to estimate, figure is 40, or even 4 into 29. I'm going to start with 7. 4 times 7 is 28, or 280 I would have. It's pretty close, and I'm comfortable that would be a good starting point. And if it's not, just erase it and go back and make it a little bigger or smaller. Try a 6, try an 8. But I think 7 will work well. 7 times 2 is 14. That's a good start. Put the 4, carry the 1. 7 times 4 is 28. 28 plus 1 more is 29. Oh, that's real good. 294 minus 294 is 0. Went into that evenly, but now I have to bring down the next digit over, which is a 5. 42 will absolutely not fit into 5. What number times 42 gets you as close to 5 as you can? Well, times 0. 0 times 42 is 0. Now I subtract 5 minus 0 is 5. So the 5 will be the remainder. So that's going to be the numerator of the fraction. And the denominator stays the same. It's the denominator from before, which is the number outside of your division problem. So you could write the number as 2,945 over 42. And again, if they say you can leave it like that, that's good. Or if they force you to change it back to a mixed number by doing the division, you can see that the answer can also be written as 70 and 5 over 42.